Okay, good morning and good afternoon or good evening, depending on when you are watching this video. My name is Victor and I'm going to be your anchor for today's training. Okay, so this is Cisco ITN and we're in module 6. If you've not liked, if you've not shared, if you've not subscribed, please do so. Okay, we're trying to look at the second layer of the OSI model. We've looked at the physical layer. It's now time to look at the second layer. Don't forget, please do not take sweet potatoes alone. Physical, data link, network link, session layer, rather, presentation layer, then application layer. Hope I didn't miss anything. So this is the data link layer, which is layer 2. So we're going to go through that. It's a very short module. Okay, good. So what are objectives? We want to understand the media access control, the data link layer, and what it supports across the network. What's the purpose of the data link layer? This is layer 2. Of course, this is where we have our switch. This is where we have our topology. This is where whatever that has to do with connecting our upper layers to our hardware, this is where it all happens. So what's the purpose of layer 2, the data link layer? So that guy is responsible for communication between the end devices and the interface NIC, the network interface card. So it allows also the upper layer protocols to access the physical layer, like I said. So the upper layer is the network layer, which is layer 3, and the layer before before layer 2 is layer 1, which is the physical layer. So layer 2 is just in between layer 1 and layer 3. Layer 1 is the physical layer, layer 2 is the data link layer, layer 3 is the network layer. So that guy allows communication between both of them. It also performs error detection and rejects corrupted frames. For instance, if data is coming from layer 1 to layer 3 and there are issues, it does some kind of correction or it drops some of the packets. So there are some standards, right? So data link layer consists of 2 sub-layers, the logical link control and the media access control, the LLC and the MAC. So the LLC sublayer communicates between the network software at the upper layers and the device hardware at the lower layers, right? Whereas the MAC sublayer is responsible for data encapsulation and media access control. So this guy is what helps. For instance, if I have a router, and I access that router, so if I have a router and I access that layer through this particular software, so the question is, what's going to be help me connect this guy to the very, very last layer, the lower layer? So that's the LLC. So this is a networking software, right? This guy here, and this, of course, at my application layer even. So you also have the MAC sublayer responsible for data encapsulation and media access control. So what's that thing that's responsible for encapsulating the data I have at the lower layer so that we can use that to communicate and tell the upper layers whatever information I have. So I've already explained in previous module what data encapsulation and data de-encapsulation is. Just wrapping of data. If you have information, you wrap it up, put some additional information for identification, then you pass it to the next level. Okay. So packets exchanged between nodes may require numerous data link layer and media transition. When you hear the word nodes on a network, it's about those end devices, right? So if you say I'm planning my network and my network have 100 nodes, that means I typically have like 100 systems or a mixture of PCs, tablets, and the rest. So the exchange between those nodes, they might experience numerous data. At each hop along the path, a router performs 4 basic layer 2 functions, right? Maybe later on, I think that should be in routing and switching in CCNA2. You got to know the difference between a router and a switch. A switch is just a junction box, a device that helps to forward packets of data across your network. Whereas a router, what it does is to transfer packets of data from one section of your network to another section of your network, right? So that's what the difference between a switch and a router. And of course, a router is more intelligent compared to a switch. Of course, also a router is a layer 3 device. A switch is a layer 2 device, right? And several other differences between a switch and a router. And when we say hop, don't forget when we did in module 2, when we talked about trace routes or trace route, for instance, where we tried to trace the route between our device and maybe SOUTECHventures.com. So I say trace route SOUTECHventures.com on my command line interface. That was in module 2, so you can check that, please. You see that for each network from my ISP here down to wherever the website is being hosted, for each section of the network, you call it a hop. So if you do trace out, you say more than 30 hops, more than 20 hops. That means that I have several networks between where I am utilizing internet, for instance, to wherever my destination is. So at each hop along the path, a router performs 4 basic layer 2 functions. So accept the frame, de-encapsulate it, re-encapsulate it, and forward it upwards. So just a moment. So OSI model, let me make it, let me just get a diagram so that I can explain that point to you. So what we are saying is that, okay, so what we're saying is that this is layer 3, this is layer 1. So we're learning, we've talked about the physical layer, which is where you have your cables, the blinking lights, all of those hardware, your NIC card and the rest. So that's physical layer. We're looking at data link layer, and we're trying to compare what the layer 3 does for us, right? This is where you have your router, this is where you have your switch. So a switch is a layer 2 device, a router is a layer 3 device. So we're trying to say that this guy, a router is going to perform some basic layer 2 functions. For instance, we say it's going to pick up whatever data that has entered into this PC is going to go through from the physical layer, from that wire, from that cable, from the wireless. It will get to the switch, right? Then this guy will have to pick whatever data it has there. So if he picks it, before it will then encapsulate what has been sent to it. So before it can send to the next layer, it will then encapsulate, that is open up what it has been sent, then encapsulates it again. That's to say, close it up again, and at times add more information to describe whatever it's been sent or whatever, and send to the transport layer. The transport layer then encapsulates, and sends and up before we now get to the application layer, which you now can use any software or whatever to see whatever that is happening. So that's how we say this layer 3 guy, this router, performs some layer 2 functions. Of course, just like layer 2 guy, most likely will not perform a layer 1 function, because layer 1 functions are typically just hardware devices, like the cables and the rest. Okay, so it accepts the frame, de-encapsulate it, re-encapsulate it, then forward it to the next guy. Okay, so there are some standards. Who are those guys that are responsible for these protocols? ANSI, IEEE, ISO, ITU, Institute for Electrical and Electronics Engineers. So because, like I said earlier on, you have several vendors, you have several persons manufacturing different kind of routers, different kind of switch, access control systems, whatever, and they stamp their own MAC address, they do their own difference addressing and whatever. So, but you must conform to most of these standards before you can ship to the market. So topologies. So when you say a topology, it's just how you arrange whatever item you have, right? We can have 10 girls, 10 boys, hold hands each other. Depending on the type of way they hold their hands can be described as a topology. If you have 10 routers, 10 switches, 100 pieces, whatever way you arrange them so that they can interconnect is what you call your topology. So there are two types of topology. We looked at this, I think, in module 1, is physical topology and logical topology. So physical topology is going to let you know whatever device that you have, where are you keeping it? What physical room are you keeping it? Is this MD, CEO room? Is this first floor, second floor, rack 1, rack 2, ground floor, all of that kind of stuff, right? So it just tells you where physically these items are. Whereas for logical topology, you are trying to say, what IP address is this guy having in that room, right? Is it 192.158.5 point whatever? What address does it have, right? What function is that particular device performing? Is it a web server? Is it a network server? Is it a DHCP server? Is it an email server? Is it whatever type of server? So you can look at it as logical topology has to do with stuff you cannot see, things that happen behind the scene, whereas the physical topology is, of course, you want to be able to identify which items where they are. And this your topology, this your plan, network diagram and network plan is not what you want to make available to a hacker or someone that shouldn't have authorized access to that kind of information. Because if you have that information, the network, the layout, the arrangement, and the relationship of all of your network devices and how they are interconnected, somebody's going to know where the MD stays, how it's accessing internet, which part is your demilitarized zone, which part is your public internet, which part is your whatever. So that's just like a schematic of how your network looks like. So you have different type of topologies. So it could be bus, it could be ring, it could be star, it could be whatever, right? So these are topology types. So point to point, just PC to PC over a cable, bus, kind of outdated, very, very recent, very, very recent, very, very recent, very, very recent. So you see this in use these days. Most of the times, for instance, if you have a router at home and everybody's connecting to that router, a printer, a tablet, a phone, a PC, a laptop, that's a star topology. If you have a switch, for instance, connected to 3, 4, 5 systems, then is that switch connected to, this might be ground floor, first floor, second floor, or they can just be in the same building, but you have 3 switches trying to distribute whatever that you have there. You might have a hard disk here that every other person is using or whatever. That's a 3 topology. Then you have a mesh, then you of course have a hybrid. Are people still use this maybe to friends, transferring data from one point to another, but typically more or less an older topology. You may not see this around again. So you have point to point, like I explained earlier on, just 2 points. Then hub and spoke are similar to a star topology. Then you have mesh. So mesh, it's most of the times at enterprise level where you want, that's this guy here, where you want redundancy. So that I'm connecting these 5 systems. What happens if this guy fails, right? And is picking stuff from here. There's always the other means. You see, I have 4 means to have access to this guy, 4 means to have access to this guy, 4 means to have access to this guy. So that's why it says it provides high availability, but requires that every end system to be connected to every other end system. Just like you see this is one item it's connected to all of the other items. So this one item connected to this, it's connected to this through this cable, connected to this through this cable, connected to this through this cable. This same guy connected to this through this cable, connected to this through this cable, connected to this through this cable, and connected to this guy through this cable. So that's like I can call it 100% redundancy. They are quasi and modified version of the mesh topology. So we say when you want redundancy, you want availability, you could implement that. Of course, for high-end enterprise network deployments. Okay, let's move on. So point to point, we've explained this. So that's what we talked about: the star topology, extended star topology, ring topology, and bus topology. All end systems chained together and terminated at each end. So you see this guy and this guy, the bus and the ring, they are legacy token ring technologies that provide two additional topologies. So they are kind of outdated. So you see this more often and you see this more often. A regular star. You have in the office, small offices, or what we call the SOHO networks, small office, home office network. They will normally utilize a star or an extended star topology, where you have a router and everybody's connected to it, or you have a router, everybody's connected to it, and that router is linked to another router or an access point outside the building, so that these other guys, they could collect data or internet from this particular guy. Why? Maybe these guys are far away, distance from this particular topology, from this particular network. So you call that an extended star topology, where you're extending whatever you have here. So all you just need is two routers, or a router and an access point and a cable, right? Here, you just need a router or a switch. Everybody connects to it via cable or via wireless. So have duplex communication. So is when you allow one device to send or receive at a time or at a shared medium, whereas full duplex is when you have back and forth simultaneous communication. Okay, so you have contention-based access. So that's what we call the CCNA. Because in layer 2, don't forget, we're trying to say, how do we get data across from physical back up, or from up down to the physical layer out of that particular device? So there are some kind of things that we need to control. Access control is very important because everybody will want to try to connect to the devices. Everybody will want to try to transfer data. So that's where carrier sense multiple access with collision detection, which is legacy. Then, of course, carrier sense multiple access with collision avoidance, used more recently in most wireless LAN. So what layer 2, what the guy does is, please, I could take many persons, but please avoid collision. I can take multiple persons, just detect. So most of the times it might not avoid that particular detection. And times you see the network is down, so you have to restart, it picks up everybody and whatever. Then of course you have controlled access. So CCNA, used by legacy Ethernet LANs, and of course CCNA, that's where you have to avoid the collision. It's devices transmitting simultaneously will result in a signal collision on the shared media. Services detect the collision, devices with a random period of time, and retransmit. So there's no actual avoidance. So you have some CCNA CA standards. So it's used by 802.11. It operates half duplex mode, whereas CCNA collision avoidance process, how it's been done is when data is transmitted, the device includes some kind of information and tells it when to stop, when to start, and whatever, so that there is that avoidance. The other devices on the shared medium receive the time, duration information, and know how long the medium will be available and when they're going to send that information. All of this is just for you to have an idea of what happens, how the switch works, and at layer 2, how it's make sure it doesn't. 10, 15, 20 years ago, we used to have hubs, right? They were not as intelligent as most of our recent switches, and even you have layer 3 switches. So we're trying to explain how these things happen behind the scene so that you don't have to be restarting your network because it just seems that you cannot send data again. So this is just what happens behind the scene. The data link frame, so that frame is that data, that kind of info that is being sent. So the question is, what info do you have there? So you have the header, the data, the trailer, right? The fields of the header and trailer vary according to the data link protocol. So the amount of control information carried within the frame varies according to the access control information and logical topology. So all of this information just tells us where we are coming from, where we are going to, how should we accept data, how long should we wait before we can send back our data and the rest. So because you cannot communicate without some kind of information. So the header, data, and trailer has all of that info. So the fields and what information that they hold. Frame start and stop, the beginning and end of the frame, the source, destination, the encapsulated layer 3 protocol, the flow control services, the payload, that data, whatever you're transmitting, which is this guy. So this header and trailer, it's just like when you build websites, you have the header and footer. Just like when you write your letters, you have the sender and the receiver, or you have the opening remarks and the closing remark. When you write a speech, you have the what's it called, the opening remark and the closing remark. When you what again, yourself as a person, you have your head, you have your tail. So all of that gives you a lot of information about the data. Then of course data is now transmitted to the next layer. So this is also referred to as physical address. Yes, our MAC address is also referred to as the physical address. At times, that's what you call your layer 2 address, and that's your MAC address. So you should understand that very well. It's contained in the frame header. So when I'm sending that information, you have to tell me the MAC address of who owns that data, that information. At layer 2, we are not really concerned about IP address, but we need to pick up that data, because if we don't pick up the data, we wouldn't know who we are going to be sending that data to. So at layer 2, we know the source, we know the MAC address that this data is coming from. Then we can now bundle up everything and push it to the next layer, layer 3. Layer 3 now gives an IP address or knows the IP address of that MAC address, then of that particular person, and now sends it like that back. So very, very important. So your logical topology and physical medium determine the data link protocol used, right? Very self-explanatory. Ethernet, or is it wireless? Is it point-to-point? Is it high level data link control? Is it frame relay? What kind of topology, what kind of protocol was used? All of that information is going to be bundled up and sent. Okay, that's all for module 2. For module 2, rather module 6, in module 6, we're concerned about the data link layer. What did we learn? We learned that in layer 2, that's the guy that intermediates between layer 1 and layer 3. We also learned that there are two sub-layers, the logical link control and the media access control, that is the LLC and the MAC. Two main topologies, which is LAN and WAN. Then there are different types of topology, point-to-point, hub and spoke, mesh. I explained all of that. Then if we are to control how data is to move from point A to B, we need to see how to control that, right? Then of course, The data link has 3 parts: the header, data, and trailer. Then, of course, our data link is also referred to as the physical address or MAC address. Okay, thank you very much for attending the module 6. Make sure you go through your Cisco Learning Management System, log into the platform, do further reading, watch most of the short videos you have there. If you have questions on the WhatsApp group or the Telegram group, ask your questions. You can also inbox me or use the link, ask your questions, and they will be answered. Thank you very much, and see you in the next module.